Okay, good afternoon, and thank you for attending this webinar. My name's Stanley, and I'm going to talk today for about 20 minutes about the characterization tool that we've been working with for the past 10 years. And to give you an introduction here, I'm going to very briefly go over what the characterization project is and how we develop those tools. But in particular, I'm going to spend time giving you some of the feedback that we received in the last few months from users. We've actually done a survey, and we've had enough use of the tool over the last 10 years that we've got a pretty good idea of what works and what doesn't work. And then I'm going to provide a brief introduction to the scientific basis for the tools, how it works, and what we're planning to do over the next year in terms of improving the tools. And then Aaron Booy of ESA is actually going to move down to an actual application at a finer bit scale in the city of Duval. So the characterization project started over 10 years ago. I worked as a watershed biologist, ecologist at Ecology, and I noticed in particular that in examining mitigation projects for wetlands and streams, that in many cases there wasn't as much success as we saw in mitigating for functions and repairing damage that might occur or had occurred previously by development. And we began to realize that a lot of the things that sustain these systems occur not within the actual footprint of those systems, but are sustained by processes, which I'll explain in a little bit, that occur in the greater watershed. So our idea behind this approach is that we could provide a core scale tool that would inform local governments' plan updates for comprehensive plans, shoreline master plans, and subarea plans. In addition, the tool also can serve as a resource for land managers, resource managers who are looking at restoration projects, might be salmon recovery project, but this can be used in stormwater retrofit, for example, and Aaron will talk about that a little bit in terms of what happened in Duval, as well as TDR programs and conservation easements. So the purpose of the characterization was to provide these three things: very general understanding of where in the landscape should one focus their actions, their activity. It is sort of a first step for planners and consultants to be able to go in and look at where you may spend very valuable time and money and looking for where you get the greatest lift biologically. And the tool is transparent enough that you can actually see why those places are relatively more or less important. So you can go back into it to see, is this area important because of recharge? Is it important because of the fact that you have higher rainfall or higher discharge controls operating within that particular watershed? And then finally, it gives you an idea of what the type of land use might be appropriate for there and what type of general actions might be appropriate. So the feedback that I wanted to cover very briefly with you is that most of the planners and most of the consultants who have worked with this found that it was a very good filtering tool. As I mentioned, it gives you an idea where you might want to put your efforts. The thing that really comes out in this tool is the fact that it does provide you a consistent coverage of the same type of data analysis across a landscape. So you get an impartial analysis that fills in gaps in areas where you might not have sufficient data outside of urban areas where there's a lot more information available. So that's valuable when you want to get a consistent approach that can be used in order to provide you feedback for yourself in terms of whether the plan that you're developing is actually on the mark. One of the things that came across too is that you really do require a technical assistance crew to help you with this plan. So Ecology does provide that. And I think one of the things that came back as problems with the plan is the fact that unless you're really well versed in GIS and well versed in watershed ecology, it's hard to take just the guidance and the data off of our website and run the models yourself. You do still need technical assistance. And so we're thinking about providing more in-depth training to provide local governments with the ability to run these models on their own. The other problem with this is that people can misinterpret the results. They can tend to oversimplify, which is dangerous, so you really do need to have technical input from hydrologists and watershed ecologists. It is not at the point where you can just give it the results to a stakeholder group and citizens and say, here, this is what we're proposing. It takes more training and understanding on their part to really get what the characterization is trying to accomplish. However, most people want a cause and effect type of approach. So they want to know exactly what a 10-acre clearing might have in terms of effect downstream. We're not there yet, but with some of the new models we're talk about later, we may get closer to that. So the scientific basis for this is research that's been done over the last 20 years. It's demonstrated that our concentration at the site specific, so the function level, which a lot of the tools out there that you're familiar with, like the wetland rating system, don't give you an idea as to what really the overall potential of that wetland or stream system is and how it operates. These systems are actually run or driven by broad-scale movement of water, sediment, wood, energy, which in turn affects the structure. So for a stream, the pool and riffle sequence and the entrainment of wood, the type of gravel and sand components that you have sorted throughout are all determined by those broader scale processes. And that in turn creates habitat niches in a system that is functioning normally, so it has a normal range of water flow. It will have a very healthy set of habitat niches and a healthy food web. It is the stressors that we introduce in terms of urban development, paving, clearing of forests that put, of course, change into the environment and truncate those water and sediment and wood processes, which in turn seriously affect the structure and function. So this analysis, if you look at the diagram on the left there, we are looking at the adjacent watershed that contributes to that channel. So we have plenty of information on the channel in terms of scientific analysis and data, but we don't have enough to actually understand what's going on in the process side. So that's what the intent of this tool. So to reiterate, there are, as we have simplified it, 3 scales that we're dealing with. There's the broad, which is hundreds of square miles, the mid-scale, which is dozens of square miles, and then the fine scale, which is, of course, where most of us operate in our daily lives as planners. This application is at the broad scale now, so we're trying to assess processes in a way that we can answer questions about broad planning actions. You know, what type of land use might be appropriate? What type of mitigation might be appropriate? Where do we need to focus our planning efforts? It's based on geology, precipitation, topography, and land cover, and it's consistent coverage of that information across Puget Sound. And you can ask some key questions about what is the integrity of a watershed above a planned restoration effort. When you see the maps in a minute, you can understand that you might be able to look at those maps and tell whether the upper watershed is intact, and this is a good site that you might want to undertake this sort of restoration action, as opposed to an upper watershed that might be seriously affected and degraded, which the maps will show you also in terms of the output for the characterization. So we have 3 volumes. We have volume 1, which gives you an idea about how the water flow and water quality processes were modeled, and volume 2, which deals with the fish and wildlife habitat, and then a user's guide. And this was to give us what we were hoping eventually to be an integrated assessment approach. And the link that I've provided there allows you to go online and download the data if you wish for all of Puget Sound, and also to go to our interactive website, which has story maps on it, examples of how to apply the characterization. So how does this tool work? Essentially, for water flow, there are 2 models, an importance model and a degradation model. and those model what we're calling delivery, movement, and loss of water. We separated it into two models because unlike a lot of other characterizations or assessments, we didn't want to just look at current conditions, because in a lot of cases we're only examining the level of degradation. We're not looking at the potential for restoration or potential for improvement in that system. So the importance model is looking at the watershed as it was naturally, without any alteration or stressors apparent or present. The water quality model is similar. It has an export potential and a degradation model. We're not going to talk about that today because we don't have time. I'm going to focus on the water flow model. So model one, the importance, is looking at the controls in the landscape that determine how water is delivered, how it moves, and how you lose it. And so there's indicators for delivery such as precipitation and rain and snow areas. There's indicators for how water moves and is controlled, such as depressional wetlands, and other areas such as permeability of soils and superficial deposits, which determine how much recharge will occur. So we can model all those by using indicators that are readily available in databases for Puget Sound. We then look at model two, which examines how those processes have been degraded. So again, going to the literature and looking at research that's been done that demonstrates that certain indicators have significant impacts upon the timing, for example, timing and delivery of water. So impervious cover, as we all know, there's a lot of information that shows how that changes the timing of water and the amount of water that reaches our stream and wetland systems. So we can model those indicators. We can do that as well with road density and well density, which affects subsurface water movement and storage. And then we get an output which shows the level of degradation to the model one importance. So here's a map of approximately the 3,000 assessment units throughout Puget Sound. So they range from approximately 5 to 7 square miles down to 1 square mile. They're larger in the upper watershed in the mountainous area, and this map shows you what has the highest importance with that model one, which is the dark color, and the lower importance, which is in the lighter blue. Now, the advantage of the characterization is that you can run these models. It's a relative comparison between these AUs running those models. So you can do it Puget Sound wide, or you can run it at any extent that you wish. So I'm going to look at RIRA 11, the Nisqually now, and you can run the model again, and you see that you get a more detailed characterization in this case, which is relevant to questions that might be asked for this Nisqually watershed. You can also do it for individual sub-watersheds, which we have done in the case of Gorse, which is a link to at the end of this presentation that you can look at. So there's a lot of flexibility with this modeling effort to answer planning questions or deal with planning questions. The second model, the degradation model, is run in this area, and you can see that around the urban areas, and it's not surprising, we see a higher level of degradation with the darker mauve color here, and then a lighter mauve in the upper watershed, as you would expect. This is forest service lands, and these lands don't have as much alteration as the lower watershed, which is seeing a lot of agriculture, such as outside of Eatonville to the west. So we then take those two outputs and we put them in this management matrix. So on the left side, we have the level of importance from low to high, and then along the bottom, we have the level of degradation from low to high. So based on what we've seen in terms of reviewing restoration efforts, areas that have high importance and low level of alteration or degradation should receive the highest protection, because we just get more value out of that. There's less work in terms of whether you take a restoration approach in trying to bring those processes and functions back. Whereas if we go to the upper right, we see that we have a high level of degradation and a high level of importance. But this is an area that you'd want to put a lot of emphasis on restoration. Now, this is where this modeling effort differs. A lot of these areas will be working lands, and under existing rating systems, for example, for wetlands, these type of degraded wetlands would commonly come in as a lower category, which under critical areas ordinance would receive a lesser level of protection. But in reality, these areas are sort of the key to seeing the eventual full restoration and return to a level of process restoration that would support recovery of not only our stream and wetland systems, but certainly our salmonid populations, hopefully. So this is the basic management matrix that we use with the maps. And then this gives you an example in the same Nisqually watershed of how this might be used. So around Eatonville, if you're a planner and you're asking a question about where you should extend your urban growth boundary, the red areas indicate that that's appropriate area to do so. It's an area appropriate for development and restoration. Whereas to the west in the dark yellow, that's a high restoration priority area, which happens to be a mix of agricultural lands. And that might be an area where you want to talk about doing offsite mitigation in order to bring back some of the wetland stream ecosystems that are in that area. And then the upper watershed, again, not surprisingly, comes out as the highest protection categories with the dark green. So we are developing future tools. One of the drawbacks of the current tool is that it doesn't give you a quantitative value, but the mid-scale tools that we're thinking of are looking at actual calibrated flow models. And so we're looking at what's known as high pulse counts, which is essentially frequency of high flows. A high pulse count is approximately 2 times the average annual flow. So the more those high pulse counts you have, the more likely a stream system is going to have a low biological diversity or index of biological integrity. Low flows are important, as we know, maintaining them for late summer and fall in terms of protecting aquatic habitat that is there. So we are thinking of using what's known as a hydrologic condition index, and then using that in an alternative futures tool on our website that would allow planners to actually place polygons on there of different development types in different locations spatially that would then give you a value in terms of its impact within that watershed. So real quickly, here is the HDI tool, and in the little diagram to the right there, you can see that what we propose to do is actually create a flow network. And in each of those, the grid network that you see, there would be a high pulse count coefficient or value assigned based on the type of land use and based on the type of geology. So for instance, an area that is forested and that's on outwash, highly permeable, would have a very low high pulse count because water is infiltrating, as opposed to something that has pavement on it would have a very high pulse count. So you can add those up along a network and get a value which then is normalized for that watershed that becomes essentially the hydrologic condition index for that watershed. And this can be compared across Puget Sound. It's based on a calibrated hydrologic model that sets up these coefficients. But once you have the high pulse coefficients, you can apply it anywhere within a similar geology type and rainfall type. And then the alternative futures tool would essentially, we haven't designed it yet, but someone could go online, we hope, and draw a polygon, select from a menu from depending on high density to low density, and then place that on the watershed in different locations, and the HDI tool would then calculate what the impact of that particular development would be. So this would be a way that you could essentially gameplay what different types of development in a more explicit way that users could see, again, getting at that cause and effect type of approach or desire on the part of stakeholders and citizens. So I provided 3 links for examples of application of the characterization tool, the Gorse subarea plan, which is the oldest, but also the Duval and Mukilteo. And Aaron Booy is now going to take take over.
This is Aaron Booy with ESA. I will talk about implementation of watershed planning in the city of Duval, really highlighting two projects, primarily the city's adopted watershed plan, which was a project that occurred over a couple of years and was adopted by the city in 2015, and then also looking at current efforts to implement the watershed plan, primarily sort of looking at stormwater planning and retrofit pre-design project that's currently underway. So the project, obviously, I was the lead consultant for the project with ESA. It was for the city of Duval. The watershed plan was under the planning department, and then current efforts for stormwater planning are being led by Public Works. It was completed through a grant from the Department of Ecology through the National Estuary Program, so EPA funding, and the King County Snoqualmie Watershed Forum and their technical staff were pretty critical throughout the project in terms of sitting on the advisory group for both projects and providing input along the way. So the city of Duval is located in the Snohomish Raya 7. It's on the lower Snoqualmie River, relatively close to the King County Snohomish County line. So the city extends from the east edge of the city's or of the Snoqualmie River floodplain up into sort of the lowland hills above the floodplain. So the historic core of the city was right along that floodplain edge and extending out of it. Cherry Creek is the last major tributary to the Snoqualmie River, and it drains into the Snoqualmie River along the north edge of the city. So the floodplain for Cherry Creek is another wide floodplain area, and steep slopes extend down from the city into that Cherry Creek area, and there's a number of tributaries that extend south up into those steep slopes into Duval. You'll see that there's three primary basins overlapping the city of Duval. Cherry Creek on the northern edge, a couple of different tributary basins called the Duval tributaries draining directly down to the Snoqualmie River along the western side of the city and taking up the majority of city limits. And then Weiss Creek, which is a basin that overlaps to the city and UGA areas on the southeastern portion of the city and drains south into the Snoqualmie River. The city was interested in this project for a few key reasons. They have experienced urban flooding and erosion issues on several of the tributary streams within the city. They also were initiating their comprehensive plan update effort, which was adopted in 2016, and so wanted to understand how to grow in the right places, where development should be focused under that comprehensive plan, and how zoning and land use standards needed to be updated to sort of account for that consideration of subbasin conditions. Also, it's definitely a community priority to protect urban trees and forest canopy across the city and through UGA areas. And lastly, considering sensitive areas across the city. Past development practices has led to a lot of change within wetlands, steep slopes, streams, with loss of habitat, narrowing of buffers, and changes in hydrology to those features. So ensuring that effective protection was going to occur in the future were primary goals both for city staff and elected officials in the community. The project was not directly in response to any one state mandate or sort of local planning requirement, but was more seen as an opportunity to sort of take an integrated approach, thinking about multiple planning efforts in a watershed sort of landscape assessment. So the Watershed Advisory Group that was established for the project provided both technical and policy input. There were 8 meetings throughout the project. As I noted previously, the King County Snoqualmie Watershed Forum was a very effective and very helpful resource for the city and for the consultant team in thinking about implementation of watershed planning and the implications of policies and recommendations that were being considered. The Snoqualmie Tribe was another partner through the project, sitting on the advisory group, and several other vicinity, very active nonprofit groups within the Snoqualmie watershed, focused on sort of a variety of different perspectives: protection of habitat corridors, protection of surface water runoff, and trying to ensure that streams are maintained as development occurs, and also thinking about specific sensitive areas or critical areas and the impacts of adjacent development. And then, of course, the Department of Ecology was involved. So Stephen's partner, Colin Hume, sat on the advisory group, and he was a direct liaison for us to the sort of Puget Sound Watershed Characterization Tool, and ensuring that sort of we were thinking through sort of use of it for this project throughout the effort. And there were City Council and Planning Commission representatives both sitting on the advisory group, as well as staff from Planning and Public Works. So it kind of gave a holistic and pretty diverse set of perspectives as to what the watershed plan, what the intent was, the technical work that was being done to make sure that it really was sort of meeting the needs of the city and was technically sound, and thinking about implications. And that's the image on the right-hand side, sort of looking at critical areas, zoning regulations, and specific management tools that were considered in the watershed plan, and getting input along the way from the advisory group to ensure that they were aligned with sort of the comprehensive plan policies that were being developed along the way. Also, there was a pretty large community outreach effort. So there's engagement at Duval Days, which is a community event, and a survey that was mailed out along with utility bills to sort of get community input. And it definitely came through that the Duval community values sort of the environmental and natural resources that are within Duval and the surrounding area, and prioritize forest cover, water quality within the Snoqualmie River and streams, habitat, and maintaining these features as additional development occurred. So I think Stephen pretty much covered sort of the graphic on this slide, but I think that the key thing I wanted to highlight is that sort of when you're looking at our WIRA level, so across the Snohomish Basin, Duval is a very small area. So the graphic shows that it's low in one of these large Puget Sound riverine watersheds. So definitely from the get-go, it was kind of thinking about the landscape position of Duval, the basins and subbasins, and sort of how this tool that was designed at a much larger scale could be sort of downscaled to sort of a mid-level assessment at that basin and sub-basin scale appropriate for the city. The key watershed processes sort of informed by the Puget Sound Watershed Characterization. The primary analysis looked at the water flow assessment, as we'll get into, and also there definitely were considerations of the water quality assessment, and then sort of finer scale data that further informed all of this landscape scale analysis along the way. One of the first steps in the project was sort of defining those smaller project assessment units or subbasins for the city of Duval. So across the city, there were 3 Ecology established assessment units that overlapped the community, and they overlapped the community and a much larger area. So each one of them, I think by themselves, was probably about the same size as the city and urban growth areas, or perhaps some of them were a little larger. So an initial step was to look at high-resolution topo, mapping of hydrology, and stormwater infrastructure to further split up those 3 main basins into 17 subbasins that were sort of representative of the sort of hydrologic landscape of the community. And along the way with this, we sort of took a finer scale look at landscape position as well, sort of understanding the differences between the floodplain subbasins associated with the Snoqualmie River and Cherry Creek, and versus slope ravine areas where there were sort of lots of ravines with tributary streams and steep slopes and erosion hazard areas and landslide hazards mapped. And then the sort of upper portion further east in the city, which sort of had more of a terrace condition where there were lots of depressional wetland features and other areas that were sort of holding rainfall and hydrology before it entered the lower reaches of those tributaries. Another consideration here is that for Duval, the study area extended well beyond the community limits. So that was, based off of input from Ecology, from King County, and the technical team working on the project, sort of considering the overall landscape and what was happening from a water flow and water quality perspective around Duval, it was important to consider not just areas within the city itself, but also sort of where those basins drained through or out of the city, including them within the study area as well. So the primary analysis was focused on the overall results for water flow. So that was that management matrix of combining the level of importance and level of degradation and those assessments. So the 17 subbasins were sent to Colin, Susan, and Stephen at Ecology, and they reran the model. And instead of binning each of the subbasin results into one of four or specific sort of categories like you saw in the management matrix earlier, we looked at the quantitative results that came back for level of importance and level of degradation for each of those 17 subbasins and plotted them to sort of see the pattern and the groupings that were established. You'll see that there were three primary groups that we identified. Group 1, including 2 subbasins. They both are the floodplain subbasins, and I think Stephen mentioned earlier sort of the importance of those areas within the Puget Sound landscape. I mean, there's been significant alteration in them, which you see that there is a moderate level of degradation shown based off of the results from previous land clearing, agricultural activity, and ongoing agricultural activities. But some of these areas, especially within Duval, there's opportunity for significant restoration because they're now conserved as open space, and there has been restoration prioritized in these zones. So they came through in Group 1. On the other end of the spectrum, there were 4 subbasins that came in Group 3, which was sort of the historic core of the city. So these are areas that drain basically directly to the Snoqualmie River. The 3 of them, actually, there are tributaries associated with. So Thayer Creek on the south end and Co-Clemens Creek, which was split into 2 subbasins, or two of the larger tributary streams, but they're within areas that significant developments occurred. So they definitely showed up as pretty high for degradation. And then most of the subbasins ended up in Group 2, 11 of the 17, with a pretty, a variation in level of degradation, but a similar level of importance. And sort of that Group 2, develop, conserve is what we called sort of the overall group, was seen as a place where additional analysis using finer scale data was needed to sort of further parse out appropriate management approaches for those subbasins. So the secondary analysis, this graphic kind of highlights the key components that went into it. We used the same sort of basic framework or idea of looking at importance and degradation for each of these Group 2 subbasins, but used additional indicators, model results to further understand what was happening at a finer scale. So the secondary importance was a combination of 4 factors, all weighted equally. The sediment export potential model, which is within the water quality assessment, was used, along with a review of modified storage, which basically was looking at depressional wetlands and other stormwater features that were holding water within the landscape, used as another indicator of importance. And then forest cover, which was a ratio of the existing forest cover base compared to the PAU or subbasin extent. And finally, aquatic habitat, which was looking at both mapped, known use by coho salmon and potential modeled presence based on WDFW data. And those 4 were all weighted equally to establish secondary importance. And then secondary degradation was sort of looking simply at a ratio of impervious surface cover to forest cover within each of the subbasins. This graph and the final map highlights sort of the results that came out of that additional assessment for protection of habitat corridors beyond just sensitive areas. And they also informed consideration of the comp plan. We'll get into all of those things a bit more. One thing that sort of establishing these 5 groups glosses over is the sort of the specific data and analysis that was done for each subbasin. So the watershed plan established a 2-page portfolio sheet for each of the 17. Actually, we reduced it a little bit for all of the subbasins that specifically overlap the city and urban growth areas. And I believe there were 14 of them. So it's sort of a presentation of key statistics, watershed assessment and watershed planning results, and management priorities and opportunities for moving forward within each of these subbasins. So this one is for Old Town, which is a subbasin that does drain directly to the Snoqualmie River. There's no natural sort of surface stream remaining, so stormwater infrastructure, ditches and pipes are conveying all runoff directly to, I believe, 2 outfalls on the Snoqualmie River within this subbasin. The sort of key, the key importance that remains is that western edge of the subbasin that's right on the river and the riparian functions, and also the impact that the water quality impact that runoff from the subbasin could have on the river. So the management priorities for this one included conducting retrofit actions focused on stormwater and improving water quality. Also thinking about incentivizing future development in this area, because it did receive that urban development management group. And one approach that was identified for that is potentially extending the flow control exemption beyond just a quarter mile from the Snoqualmie River, and encouraging people to take other actions focused on water quality and focused on restoration or stormwater improvements elsewhere in the city, higher priority areas in the city, as opposed to putting money into stormwater vaults within this subbasin. And then continuing to ensure through the shoreline management program and through open space management that the riparian corridor is maintained and enhanced along the river directly. Another one, this is the North UGA on sort of the northern edge of the city. It was landed in the group lowest conservation, which is actually just the next level above urban development. This one, however, there are some key features that do remain despite the sort of intense level of development that has occurred, at least within the city. So Lake Rasmussen, which is one of the larger lakes, it's still not an SMP managed lake, but I think it's around 14 acres in the city, is the headwater of Cherry Creek Tributary A, which is the largest tributary to Cherry Creek flowing through the city. It's mapped with coho use. And there's known water quality impairment and issues with Lake Rasmussen and the Cherry Creek Tributary A. So management measures, really priorities focused on protection of stormwater, retrofit of stormwater runoff to Lake Rasmussen and downstream into the tributary. And then also focusing on development within the North UGA area. So the whole eastern portion of this subbasin extends into North UGA, which is one of the primary areas where the city is anticipating development in the not so distant future. So setting up some pretty clear expectations as to how the resources that remain, the forest cover that remains in that area should be conserved, as sort of an integrated approach as that future development occurs. And then my last example is another urban growth area. This is within the city's UGA reserve. It's an area that was scored as highest conservation. So outside of the floodplain extents, this portion of the city was seen as having the highest conservation value and was still relatively intact. So a high level of forest cover, pretty extensive mapped depressional wetland features that were in a headwater position to some other Cherry Creek tributaries that were primarily outside of the city. So the management priorities for this area actually suggested to the city that potentially it would be better to look at other areas for future urban growth. That informed a comp plan to an extent that the sort of comp plan took initial steps to considering the possibility of removing this area from the urban growth area reserve and looking at other areas where, from a watershed perspective anyways, additional development might be more appropriate. So those are just 3 of the pages from the Watershed Folio. as far as watershed plan implementation, I talked about this a bit already, but one of the key immediate benefits of this watershed plan was informing the comprehensive plan update for the city. It informed both the EIS environmental review, so all of this analysis was factored into consideration of the different alternatives for the comp plan that were reviewed in the draft EIS. It also provided clear and actionable direction for future growth and development within the city. So again, that was primarily focused on those urban growth areas and other focus portions of the city, kind of in the southeast portion where there is a lot of additional development opportunity, and setting clear policies as to updates that the city is now implementing to land use and development standards to ensure that that future growth is consistent with the watershed plan and policies that were integrated into the comprehensive plan. So at a very high level, these new policies sort of focus more growth, prioritize more growth within groups 3, which is the urban development portion of the city, and groups 2C subbasins, whereas it really prioritizes restoration and conservation within groups 1 and 2A subbasins. And sort of the spectrum as we're implementing these actions sort of take incremental actions to increase protections as you get closer to those subbasins that are assigned group 1 and group 2A designations. So this was a tool that was put together for the adoption effort to sort of focus in on the North UGA and assess the implications of the watershed plan as it was integrated into development standards, or as it was sort of envisioned to be integrated into development standards. So the left development scenario for the North UGA sort of shows a development pattern somewhat consistent with the city's existing regulations, where you had sort of some impact to lower value wetlands, fragmentation of the other sensitive areas or critical areas that remained on the property, and designation of open space in a way that really didn't integrate with sort of an overall approach to maintain connectivity and sort of foster the community's value of those native growth protection areas. And then the watershed plan development scenario on the right-hand side, there's a few things to highlight here. One is sort of maintaining those connections, because the eastern portion of this North UGA is, I think it's in group 2B, which is an area where a higher level of protection would be required. You'll see that that wetland impact that's shown in the standard development scenario disappears. That creates habitat corridors across the site. And then there's also some features that highlight sort of more of a dispersed stormwater approach that integrates green infrastructure and LID approaches. Areas where right-of-way crossings through these corridors are narrowed to minimize the impacts there. So it's sort of conveying the message of the direction the city was taking. Currently, the city is updating their sensitive areas regulations following the adoption of the comprehensive plan. The watershed plan approach is definitely playing into protection both for sensitive areas and tree protection, and looking at sort of a variable scale of protection based off of the underlying subbasin management or watershed management group. Also implementing protections for habitat corridors, which was prioritized through the watershed plan, and implementing the integration of standards for open space when subdivision occurs and tree protection. So all of these efforts are sort of occurring separately and more of an approach that results in maximizing the buffer width that is maintained around important resources, while maybe allowing for a little bit more impact and additional development opportunity within those subbasins that are prioritized for additional urban development. And then my final couple slides highlight the efforts underway right now, looking at surface and stormwater and updating the city's comprehensive plan and implementing retrofit projects. So this is sort of an additional downscaling of kind of this landscape scale assessment to understand and prioritize different areas with a stormwater management perspective differently. So this map shows the city's stormwater facilities across the developed areas, so primarily residential subdivisions, and it's color-coded displayed by the design basis that's underlying each of those respective drainage plats. So that's a key data layer that the city is using to assess really the first of these two primary objectives. So there are two primary objectives looking at both existing platted areas and the existing stormwater facilities within those areas, and then also looking at areas of the city where future developments occurring or expected to occur. So some of the less developed areas and the urban growth areas. So for the assessment of platted areas and existing stormwater facilities, the first primary objective, the performance of existing facilities based off of that design basis was seen as a key component to sort of understand at that drainage plat level where retrofit opportunities should or probably are of most value to the city because of sort of the design basis and the different standards that were associated with stormwater management manuals at different times. There's sort of a different scoring for water quality versus flow and erosion for each of those design bases. The intent of that is to inform a retrofit ranking that the city's using to basically prioritize capital improvements to existing facilities, and the highest ranked retrofit opportunities will be selected for pre-design efforts to go and get them closer to actual on-the-ground improvements. And the second of the two objectives, again, is looking at those areas where additional development's expected. So there's not existing performance of facilities there. So it's actually taking an approach that's more similar to the watershed characterization. So it's looking at the level of anticipated development that's expected in different areas, the watershed management score, and then sort of the vulnerability or environmental importance of those different areas to ensure that there's an understanding and policies can be established that stormwater management and future stormwater infrastructure includes appropriate measures to maintain the functions that remain in those areas. So for the future development toolbox, this is just sort of a draft initial slide, but it is taking that same approach where the x-axis is looking primarily at sort of both the watershed management group designation and with an adjustment for zoning. So it's kind of assessing the importance at a sub-basin level and anticipated future development. And then the y-axis is looking at the sort of sensitivity of the receiving water body either to erosion or to water quality and the proximity of the drainage plat or the development area to those specific features. And based on that, sort of setting high-level priorities for what should be expected. So long-term, the city is hoping for smart growth, improved protection of natural resources, and reduced issues occurring. So this is the pictures of an eroding slope above Clemens Creek with a playground area at the very edge of the top of the slope. And the city has taken measures both down in the stream channel and up in the park to stabilize the slope. Has also already implemented some retrofit actions upstream of here to try to sort of improve the stormwater runoff and those peak flashy flows that are coming from older development within the community. But we're trying to help the city avoid these sorts of situations in the future. This is my final slide, just highlighting sort of where we're at and the ongoing implementation, and it provides a link to the Duval Watershed Plan webpage, which has all of the adopted documents. You can get into that sub-basin folio and some of the detailed assessment approach and policies that were put in place. Thank you. So the first question I'm seeing here, so it was more of a qualitative survey. There was good response. I think we had over 250 responses, but statistical analysis wasn't done on that response. It was just sort of done to kind of further augment understanding of the community perspectives that we were hearing from the Planning Commission, the City Council, and that were informing the project effort. But there was no statistical analysis done. The next question is, did the two watershed plan implementation scenarios have the same resulting density? They appear to have differences in possible achieved density. So yeah, that is I think that's a great question. And it's something that the city's grappling with now. They have sort of standards for calculation of site density as subdivision occurs. In the past, at least 10 years or so, maybe longer, they've used a gross density calculation that doesn't actually subtract out any of those sensitive areas. So it sets an expectation for density that doesn't always work on an actual property when there's sensitive areas, when you're thinking about all the infrastructure that's required. So that slide, I can back up to it real quickly, potentially. Maintain a pretty close parcel count, or I'm sorry, not parcel, but housing unit count. So you'll see that there's incorporation of sort of a cluster housing approach around a couple of open space areas. So those are kind of the thought being that smaller lots could be incorporated in. And then also the red features are sort of courtyard or corner housing, sort of duplex or potentially even triplex townhouse type features that sort of have more of that character of a single family housing arrangement. So you're sort of actually building in other types of development within these single family communities. And this is very much conceptual, but the devil is in the detail, and the city is working hard to sort of factor in the further implications of the watershed plan, habitat corridors, additional protections for sensitive areas, and the expectations for density on properties.
The next question, are there any examples of this planning tool being applied to county level planning? And there are a number. The most recent one, which I'd recommend looking at, is Thurston County and their Deschutes watershed plan. And I can send that link afterwards to the Stormwater Center. Maybe that could be sent on to the person. They can post that. There's also been work done by Snohomish County and King County jointly in RIRA 7, which was done in 2013. That was an attempt for salmon planning to find the areas that had the highest priority for benefiting salmon restoration. And a number of others which have been done in Kitsap County and Inlu Feed program that is probably 2011, 2012, but I can send along a list of those.
And the next question is, will the city require mitigation to be conducted in high conservation areas? Would they implement an in-lieu fee area? So the city definitely has already taken the perspective, since adoption of their last sensitive areas update back in 2005, of sort of allowing for some offsite mitigation, especially for buffer impacts, buffer reduction, those sorts of things within those highest conservation areas down in the floodplain area, which is primarily city-owned open space with lots of restoration opportunity. And I think this watershed plan sort of gives them further analysis that's consistent with that approach and policy direction to continue that as the sensitive areas code is updated and future development occurs. There's also a wetland mitigation bank not that far downstream, so that's utilized as well. But sort of both of those approaches, depending on what the impact is, are considered by the city, and definitely they use them as opportunities to kind of prioritize and get restoration occurring in areas where it could make the most difference. Is Duval considering requiring stormwater management requirements exceeding the current ecology standards in certain basins? So I think that they're definitely considering different stormwater management requirements for different areas around the community. So I talked a little bit about sort of the Snoqualmie River as a receiving water body within a quarter mile, and considering opportunities to extend or expand that flow control exemption to other areas where there is sort of existing infrastructure that provides conveyance down to the river. So that's actually sort of allowing potentially for additional development in those areas. And then in other portions of the city, I'd say the city's looking at sort of defining the expectations for LID and green infrastructure approaches based off of the condition of those areas where future development's expected. So maybe, I know that the newest stormwater manuals are creating an expectation for use of LID approaches. So it's kind of putting some parameters around that so the city can understand and anticipate what's going to be occurring and have more sort of a document to rely on to ensure that it's consistent with what makes sense at the landscape level.
I might add also that the City of Redmond has done us a watershed-based stormwater plan, which we can also send the link to, that they use the characterization in a certain form of the characterization to prioritize stormwater restoration retrofit methods.
Thank you all for spending this hour with us.